All right, so just like we did with arithmetic sequences and just sequences in general, now we're going to look at their series. So what happens when we add all the numbers together? And so what I'm going to do is I'm just going to quickly discuss where the formulas come from. Okay, so I just want to quickly discuss where the formulas come from. You don't have to recreate this. You just need to know what the formula is. So just make sure that you know the formula. But I do want you to kind of see where it comes from. Just like we looked at where the formula comes from with the arithmetic. The geometric is not quite so obvious. So just follow along just for a moment. So here we have what it means to add up a geometric series. So the first term would be a sub 1. The second term is a sub 1 times r, a sub 1 times r squared, all the way up until the nth term would be a sub 1 times r to the n minus 1. That's how we find the nth term. So this is what it looks like if we add them all up in generic terms. To find a formula, what was done is taking that and timesing it by an extra r. So you can see what happens here. R times s sub n is, you'll just notice that every single term has an extra r. So the first term has an r, the second term now has 2 r's, the third term now has 3 r's, so on and so forth. All the way to the last term now, instead of being 1 less than n r's, it actually has n r's. Alright, so why you can do that is because what happens when you then in turn subtract those two things, so s sub n minus r times s sub n, you'll notice that there's a lot of overlapping terms in this sequence, in these sequences. So what actually happens is if you take this equation and subtract this equation, those would cancel out, those would cancel, this next term here that I didn't have written would cancel this out, and all these middle terms would cancel, this would cancel with this term here, this would cancel with this term here. So what we would be left with is just this very first term minus this very last term. And from there we can subtract, or we can factor out an s sub n, and we can factor out an a sub 1, and then divide by the 1 minus r on both sides, and we end up with this formula here. So here's the formula, here's what you need to know. I just want you to see where that formula comes from. So this is just so you can see where the formula comes from. This is the formula that you need to know. Alright, so we need to know it. Now let's use it. Alright, so we want to find the sum of the finite geometric sequence. So here we're starting at 9, 27, 81. So you can see times by 3, times by 3. We're going up to 7 terms. So to find that sum, it's the first term times 1 minus the common ratio, which is that number that was being multiplied, so 3 to the n power. N is the number of terms. We're taking 7 terms, and then divided by 1 minus 3. So in the bottom, our denominator, we have a -2. And then in the numerator, let's go ahead and type that into our calculators, because that I don't know off the top of my head. So if we take 9 times 1 minus 3 to the 7th, we should get negative 19,674. So then if we divide that by 2, or -2, we end up with a sum of 9,837. Alright, so here's one that hopefully none of you guys have had to deal with too many times, but you guys may have a time or two. So Mrs. Shanka charges students $5 to buy back their phones when they get it taken away. After the first time, the buyback price doubles. What is the total amount that a student would have to pay in a school year if they get their phone taken away 5 times? So if you get caught with your phone 5 times, what would be the amount over the course of the whole school year that you would have had to have paid? So it starts out at 5, then it goes to 10, then it goes to 20. so on and so forth. So you can see that this forms a geometric series. So if we take that first term times 1 minus, it's doubling, so it's timesing by 2. If it happens 5 times, let's go ahead again and type this in. You will have paid a total of $155. Moral of the story, don't use your phone, don't get it taken away. Alright, so now let's look at it in the terms of the summation notation. Same concept, but again, before you can apply that formula, just like we said with arithmetic sequences, before you could apply that formula for arithmetic sequences, you must know it's an arithmetic sequence. Same rule applies here. Before you can apply that formula for a geometric sequence, you must know it's a geometric sequence. So again, you may recognize the format because it looks the same as what that explicit rule is, but if you're not sure, go ahead and write it out. So when n equals 1, that would be 1 minus 1, which is 0. Anything to the 0 power is just 1, so that you just get 12 times 1. Then when n is 2, you have an exponent of 1, so that's 12 times negative 1/2, which is negative 6. Then when it's 3, it's to the second power. Second power is positive 1/4. 12 times positive 1/4 is positive 3. And you can see that something is being multiplied each time. It's negative 1/2. So we know now it's a geometric sequence, so we can use our formula for the geometric series. So first term times 1 minus negative 1/2 to the, we're adding up 12 terms, so it's the 12th power, all over 1 minus negative 1/2. That's plus 1/2. That's going to be 3 halves on the bottom. Make sure when you type this in, you put your negative 1/2 in exponents, or in parentheses, excuse me. And we're taking it to the 12th power. Times it by 12, and then you get 11.997, and we need to divide that by 3 halves, which is 1.5, and you get a total of 7.998. All right, so I'm going to jump back for a second. So if we looked at this one, you'll notice that this answer is actually pretty close to 8. And if we continued on with adding in more numbers, so let's say we went to the 30th number, the 30th term, so I'll just quickly type that into my calculator. So negative 0.5 to the 30th power and times that by, oops, sorry, hit a button wrong, I gotta retype it in. So negative 1/2 to the 30th power, and then minus 1 minus that number, and then times it by 12, divided by 1.5. you end up with 7.999999999. So pretty much you're getting closer and closer to 8. If we kept going with this, that's 30 terms. If you went up to 100 terms or 1,000 terms, you'll notice that the answer just keeps getting closer and closer to 8. And what's happening here, why it just is getting closer and closer to 8, is because what we have here is we have a converging sequence. Okay, because I'm timesing by a half, even if it's negative, what that's doing is that's cutting the number in half. It's also switching the sign, but it's cutting the number in half each time, which eventually when you get to the 12th term, or the 30th term, or the 100th term, those numbers become extremely, extremely small, to where eventually they become essentially insignificant. So that brings up our last thing that we're going to talk about, is infinite geometric series. And to find the sum of an infinite geometric series, first of all, the geometric sequence must converge. Okay, so it means it must approach 0. This will only happen if that common ratio, that thing that's being multiplied over and over again, is between -1 and +1. So that's the only way that that number is going to keep getting smaller and smaller and smaller and smaller. And so if it's an infinite geometric series, the formula is simply a sub 1, so your first term, divided by 1 minus r. So let's take a look at that. Hold on. Oh, sorry about that. Okay. So here we have 2 times 2/3 to the n minus 1. Again, this is a geometric sequence. You can notice the pattern, that format. That's the same format as all geometric sequences will look like. And here we're looking at to infinity. And so before we can do that, we have to look at that common ratio. Make sure that that number is between -1 and 1, because if it's not, the answer is not possible, and that's all you do. You just write not possible and you move on. This one is 2/3, which is between -1 and 1, so we can find the sum of this one. So it's going to start with the first term. If you plug in 1 here, you get 1 minus 1, which is 0. 2/3 to the 0 power is 1, and 2 times 1 is 2. So you've got 2 over 1 minus your common ratio, which is 2/3. 1 minus 2/3 is simply 1/3. And 2 divided by 1/3 is the same thing as 2 times 3 over 1, which is 6. Alright, so we've just got a couple more examples of that. Here we've got another one. Again, it fits that geometric format, so we know it's a geometric sequence. We're going to infinity, so we need to make sure that this is between -1 and +1, which it is. So we need to find the first term. So when n equals 1, that's 0. Anything to the 0 power is 1. -3 times 1 is -3. And then 1 minus -5/6 plus gives you -3 over 11/6, which is the same thing as -3 times 6/11, which is -18 over 11. Alright, last one, again, fits the format of geometric. It's infinite, so we look here first. Make sure that that common ratio is between -1 and +1, and 6/5 is more than 1, so this one is not possible. And that is all.